Topic is TurboBoost your product development with Agile Hardware. 10 times faster with better quality. And I think 10 times is a little bit kind of like, I could say 100 times faster, but then we decided maybe 10 times is better. You know, you need to be modest if you are from Finland. So who of you work in product development? Yes. Who are Agile coaches in product development? Excellent. So I hope this is going to give you some ideas and tools for the future. So I actually was rushing last week to put out a second or third white paper on Agile Hardware. And both of these hardwares that I'm going to include in the talk will be available to you afterwards somewhere. So, and someone commented in LinkedIn that, okay, Agile legend, when I was publishing it, and I was thinking like, okay, should I be flattered by this, or should I not be flattered by someone calling me an Agile legend? Like, legend is something that is kind of past, right? Doesn't really know what they are talking about, and I still feel that, okay, I want to contribute. But to be honest, I started my Agile journey in year 2000 with Dr. Alistair Coburn, who in 2001 asked people to ski in Snowbird in Utah, and out came Agile Manifesto. So I started a year before Agile Manifesto. I spent 10 years. I spent 20 years in Nokia. I started as a software engineer, done 10 years of traditional project management in waterfall style. And then 10 years, I started to figure out what is Agile in scale. How can you scale it in large organization like Nokia product development? And out came a dissertation, which was first of its kind, Agile at scale. And also led the Agile transformation at Nokia mobile phones, first on the smartphones and then 2009 in basic phones. And I asked several coaches to come. Actually, I was in a position that I could ask all the gurus at that time to come to teach us. And one of the persons I asked was Dee Leffingwell. And he picked pretty much everything we were doing there, and out came SAFe framework. So I became a SAFe fellow. I've been training that for quite many people. But actually, I didn't reveal everything to Dee Leffingwell. So already in 2010, we started to look about how we were doing hardware. And that was happening by the top management actually appointed me to change how we were doing hardware. Because we figured out, but when we were having these incremental releases with the software was first time kind of keeping the schedule. And we had this saying that software is always late and hardware is on time. And we were able to first time pinpoint that, hey, now the hardware is 3 weeks late. The prototype is 3 weeks late. And it's not 3 weeks that it's causing on software side. It's more like 9 weeks or even more. And that was a shock. And we realized that if we have slippage on the hardware side, it's causing more severe slippage on the product deployment. And the top management said, Maarit, you need to change that. And we said, okay, let's try to do workshops. So let's find people from the hardware side who have been here a long time, who are recognized experts, and who also know something about processes, who don't really hate processes. So I started as a software engineer and hated processes. So that's how I became Agile coach, of course. If you hate processes, you try to bend the rules, like, okay, you know me already. And yeah, so we had different groups, and they confessed to me later on that we thought we will ridicule you, and but then something happened. We noticed that everything that you were talking was not BS. So actually we had to start implementing and piloting some of these. And so I wrote a kind of a research paper out of that. I think it was published in 2014, so you can find it. It's publicly available, Piloting Agile Practices in Hardware Development. And since then, I've been working with multiple different hardware companies. And you know, every time I go to different type of company, they say, yeah, you work there, but that's not hardware. That's not our hardware. If I go to chip manufacturers, they say, yeah, but the printed circuit boards, that's not really hardware. We are doing microcode. Or we are doing ASICs. And some other guys say, well, but ASICs, they are almost like software, but we are doing really heavy hardware, so what you did there doesn't apply to us. So, what is the challenge that we are living in? This is the world that we are living in. You know, what is happening now with the war of Ukraine is we have these drones, you know. And if you've been following what's been written in the newspapers, they say you have to have new variants in weeks. Not in months, not in years, but in weeks. Because there is ongoing competition how these are done. And if you think about any bigger product that we are building, we are not having variants in weeks. We are having variants in years. And I started to talk with one lady who has been working with military for 20 years. And she said, we have this challenge. What we have been building has been taking 16 years. And now we should be ready in 1 year or less. So how can we do this? Shrink the project's duration from 16 years to 1 year. And another challenge, the flexible government contracting. So we have used to write all the specifications and then ask a tender based on the specifications and then deliver based on the specifications. And we cannot do that anymore. And of course, maybe all people out there, they are not following the same rules, which makes this harder. Okay, let's tackle this one by one. So from 16 years to 1 year. This is a starting point. Often when I go to companies and they say, you know, hardware is hard. It's by definition, you don't understand hardware is hard. You can't do it in an agile way. I heard it more than once. And I always pick this slide. You know, if you have a bicycle factory and you have just 5 different subsystems, and there is a probability that you get it first time right, because this is what we often want to do with waterfall. And there is a 20% chance that you have some error, which is causing you to do some rework. You know, the probabilities, you calculate them, you multiply them, and then you get the overall probability of success. And this is kind of leading you in a very bad condition that you might get a success. So don't try that. Don't talk me that waterfall is just fine. Let's just run faster in waterfall, and then we are going to do this 16 years in 1 year. It doesn't work that way. On the contrary, when we talk about agile hardware, we can talk about, for example, SpaceX. So SpaceX actually started with so little money that people ridiculed it. They said, no one can build a spaceship with that little money. And so what they did, they started to apply techniques from software into building the spaceship. And they did it in modules. And of course, if you build it in modules, so that each of the modules adapted from the software world, this object-oriented approach. So you're not starting from the system architecture that you draft the specifications for the entire rocket. You are starting from the fact that, okay, if I'm this module over here, I need to be able to adapt to my surroundings, whatever that is. And that means you are adapting to the world that is out there as this module. So it makes this problem a bit smaller. Building this module is becoming easier, and maybe you can done it by a smaller team. And it overall speeds up the development significantly. So the story of the SpaceX, of course, the first 3 launches, they failed. And what happened? They had enough parts, so they didn't have money to build the fourth rocket, but they had the modules, and they were able to build it together. And the 4th launch was a success, so that's why SpaceX still exists. And here is actually a real product, and some of the modules from it, not all of them, just some that I took in this picture for illustration, that you can also think these bigger other entities like trucks in a smaller modules. Okay, so these independent modules, they are actually what enable this business agility. And they enable the configurability, They offer tailored solutions for different user groups, volatility, upgradability, sustainability, and even some different kind of business models. My second white paper is about these business models and how actually this kind of change that we are talking about, digitalization in product development, is enabling more sustainable world. So how do you get there? So the first step is to identify what are your modules today, because modules are nothing new in hardware development. We have for decades actually used different modules. The thing is, the modules are interdependent at the moment. So you have to integrate everything together, and then you test it as a plumb, and then it's launched. And that is something to look at. And when you start to look at, okay, what is the iteration cycle? Because the ones modules that cause you to go over your project deadline are the ones who are having the longest iteration cycles. And how do we know what is our iteration cycle? That's when we get the feedback on whether we succeeded in building it and whether it works or not. So concrete feedback. And this is when it gets non-fluffy, because this is actually a good question. When do we actually get feedback if this works or not? And guess what? The first thing that I asked the hardware engineers who were doing the PCB board at Nokia, I asked them to pair up with the people who know similar type of work and get a feedback, explain them what they are doing. Like, you know, how we started to work in software side in pairs, explaining how our code works. So the same thing can be applied in hardware development, and you know, they hated it. They hated it, but it was helping with the quality a lot. So when we know about the iterations, we also need to understand what is our value stream. So how do we actually come with these parts? How do we come with the final product? What is happening there? Where is the time consumed? And why do we need to know that? It's because we need to know where our bottlenecks are. And we need to understand those bottlenecks and maybe start to work somewhat differently over there. And then a good question is, when are we able to release this? And for that, you need to implement the rolling planning. So once you understand the iterations, you can have this higher, more coarse overall schedule, and each of the iterations you plan in detail. And now the difference between the software and the hardware is that I suggest that these iterations on the hardware level are stick in the actual factual feedback. So when you have something that you have tested, and when you know what, if you need to do another round for that design, that's the start of the next iteration. You cannot, like software, you can split in arbitrary lengths. You can say, okay, this is where I want to start my next increment. And you can't do that on the hardware. You need to understand what is the cycle length and how you can play around, and you need to kind of formulate this structure around it so that you can have this rolling planning. And once you have executed an iteration, then you kind of reflect your learnings to the overall schedule. So when we did this first time, we actually studied all the data that we had, and we found out that even though we had this like do it right the first time, we had always had 3 iterations before we were ready. And when we started to plan these 3 iterations, we noticed that, okay, suddenly we can keep our schedules because we are based on our planning on the data and not some kind of wishful thinking. The thing is, some of these hardware modules, they have longer iteration times than others. And now if you have this kind of situation where it takes 6 weeks for some bigger part to do the iteration and 4 weeks for some smaller part to do the iteration, you can quickly see that, okay, you cannot allow this to iterate on their own, because you need to, at some point, you need to have this synchronization point where you kind of see if that is working together or not. And these synchronization points are actually really, really important, because in the past, you know, how we have been controlling our product development is through milestones. And you know what is happening always with the milestone review? Milestone reviews are combining a big monetary decision, typically with are we ready? What is our maturity level? And that's a problem because you know we always have to pass the milestone in order to get the funding for the next round or the funding to go forward. And often we actually pass the milestone with exceptions. And the exception means, well, it should be ready by this time, but we actually need to fix it. So it's better to base your milestones on this factual synchronization point, like, okay, this is measuring the maturity, and you can have separate decision points for, okay, how are we going to do the further investments? And I suggest that you have actually a couple of these synchronization points. So you need to speed up so that you have a couple of these synchronization points that you know your design is actually working before you actually use more money. There is also other things that you can do in order to spend your money a bit more wisely. So a lot of what is in the Agile hardware, and I don't go through all of that here in this presentation, is ways to put the cost down. And a lot of ways that we can put the cost down comes with the software. And we can, for example, in a car crash, we can simulate the impact test, and we can build these prototypes to match the simulation before we actually run the actual test, which is then more money consuming. And then we update the simulation with the actual data, and then it's accepted by authorities to meet the regulatory needs. So I remember long ago when I was still working for Nokia, I was thinking that everything else can be done in agile fashion except this type approval test. You know, that's the test where you see that the radiation from the phone is not exceeding the legal limits so that it's not boiling your brain. And then one day, these guys who were responsible for this type approval test, they came to me and they said, we have now noticed that everyone else is doing agile, iterative and incremental development. And we have been thinking that, what does it mean for us? And I was thinking that, oh no, where do I hide? Because I don't know how to say anything to you. And then they said, well, we have noticed that if there is severe errors, we can figure it out from the earlier increments. And then we can do just the delta testing because the laws actually allowed us to do just the delta for the latter increments and see that it's still okay. And that is actually saving us both the schedule and a lot of money. Because if we notice that there is severe errors in the earlier increments, we may still have time to correct it. And actually, if we catch it earlier, it saves a lot of money. And I was like, wow, I could not have told that to you. And since that, I've learned it over and over again in different environments. Like these things that people think that are really, really hard to do, like getting type approval, getting authorities approval. If you are able to take them earlier, it's actually those things that are paying back most. And that's a little bit controversial because we often cannot, as an agile coach, it's hard to sell this transformation. You have to go and you have to sell it to some company CEO or CFO or CTO or some other authority who can say that, yes, let's do this transformation. And when you start this journey, it might be hard to say that, okay, what is the actual payback of this transformation? If you can say, okay, 16 years to 1 year, that has some actually business impact. That might be something that gets the attention. I was discussing with one guy. So this is a story. So a couple of years ago, I was lucky enough to make a hardware training in a company. And they started this transformation. And in my training, I had this video of this rocket that is being printed out with a 3D printer. So you know there is this Relative Space, that's a company who actually prints out entire rockets. And it has been flying out there and landed back in the earth. And I was saying that, hey, this metallic printing might be a nice idea. But the company top management, they thought that, okay, is this going to save us some money? Why would we invest in this 3D printer? I don't know if this makes any sense or not. And I said that, hey, in an agile way, can we just explore this? Let's buy a small printer and see what we could do with it. You know what, just a couple of weeks ago, I saw the impact. So not just this company, but entire other companies in this area are now having this very huge community, which is focusing on 3D metallic printing. And I was lucky to visit the production facilities and see this place where they had kind of a huge 3D metallic printer. And I was asking like, okay, what good does it do to you? And they said, you know, we are located here next to the door to the manufacturing site. And everyone who is going to manufacturing site, like the workers, they pass our facilities. And so they see what we are doing, and they ask questions. And they come to us when they have problems in the manufacturing. You know, this thing that was designed this way doesn't quite fit, and I need to quick refix. Or something that I ordered wasn't arriving, and I need something to continue my work. And we can, just in 24 hours, help them. And that is actually saving a lot of money. But would we be able to kind of do an Excel sheet calculation on how much you would save by putting that 3D printing facility there? I don't know. Maybe you can do some Excel math in kind of like how much you can save when you are preventing the production on stopping. I don't know. Sometimes these kind of things, what you can have, how much time you can get, it's hard to estimate in the beginning. And then you actually, when you start walking, you see suddenly that you are running and you gain so much more than you could ever imagine. And then when we had this presentation of this 3D printer, one person said that, yeah, but you know, you have all these compliancy requirements. Are these 3D printed parts, are they compliant? Yeah, because they are 3D printed, they are actually more sturdy. They are better than traditionally manufactured parts. Yes, they are. Okay, what is happening now in manufacturing is actually a revolution. I believe that's as big or even bigger revolution than what kind of, you know, how agile methods became popular. It was because the computing power was enabling automation, such as DevOps, which first started as a continuous integration within a team, then continuous delivery, and finally DevOps. So we needed these fast iterations. We had a tooling that was supporting these fast iterations. So that is actually a revolution that is now happening in manufacturing. There is something called microfactories, and there is a lot of robotics happening, which is enabling different type of manufacturing than what we have had before. So the way how we have operated so far in product development is basically we have had all the time in the world to spend on R&D to create a design. And then the manufacturing has been just reprinting that like a big copy machine all over again, because that's been kind of like an economical way of arranging that. This fundamental is now changing because of the robotics and because of what we call Industry 4.0. And the digital twins. So we are able to collect this, all the data, and we are able to do products that feed us back data, where we can use this data to develop our products further. So for example, if you think about self-driving cars, we can have that data on how people are actually driving in actual conditions to fed back in our systems, and we can use that for teaching our cars to drive on their own. This kind of level 5 driving, where it's completely autonomous. It's also, I talked about the sustainability. So, you know, there is European Union is setting different sustainability requirements. Netherlands, for example, in 2030, half of the raw materials should be circulated, what we use in product development. We need to have an understanding, somewhere needs to be a digital footprint on what you actually used and how it can be reused, and wherever is a better place to save it than in these digital twins. So we actually need this for multiple reasons. So what is actually happening is that the old division to hardware and software departments doesn't make sense anymore. So you have to have cross-functional teams where you have software engineers who are creating these hardware simulations, and testing expert, and a manufacturing expert. And this is, by the way, not a dream. I know companies who have now changed their structures to work this way, because this is fastest. This is a difficult change for hardware engineers. We need to help them as coaches on going through this change. And we can go in this incremental approach. So this slide is actually really old. This is the vision, and this was how we actually started to perform in Nokia mobile phones. Long time ago. Product increment after product increment. We were going in a direction where when I left the company, we were in one part of the development, we were having pixel perfect phone with hardware software iterations every day. I never thought we could run that fast, but we actually did. So this is where my story with Show Justice started. So 5 years ago, I was organizing this Scan Agile conference in Helsinki. It was before the COVID times. And I was impressed by Joe Justice's wiki speed. So using Scrum to build a road-safe car. I think that was cool. And I said, hey, why don't you come to speak in Helsinki? And Joe basically agreed. But then COVID came and we couldn't have it. And Joe's business was actually gone because he was a speaker around the world. And because of COVID, he couldn't do that anymore. So we started to discuss. And he said, yeah, but I only worked on the companies who are kind of digital software first and going really fast. I don't know how to transform old companies that are traditional, who have been using waterfall. I don't even know how they work. And I said, but that's my part. I've been doing that. And we decided that we will start to work together. And the outcome is actually that new white paper that I just finished last week. So it's been like a 5-year journey to write that white paper. So it's written together with Joe. And it's our best understanding on how to get in the speed. So when you have this, set up these increments and you have this like incremental development, you start to measure the flow. You start to understand what is in the system, how fast are you developing, and what is the throughput. And then you have start to improve the flow. So you start to understand why is your longest iteration so long that it is, and can you somehow split that module into two? Can you somehow work on the architecture? Where is the bottleneck? And how can we actually improve that? Okay, we come to regulations. So you know, long ago, when I was still a software engineer, I had colleagues who were working in a new product with whom I had been doing a product before. And they followed the process that we had at that time. So they spent 1 year on writing specifications and other year building the product. And when the prototype was ready, the management said that, nice, but we are not launching this because it's outdated. 2 years development time was too fast, too much. So we couldn't launch it because it was outdated. And that was a kind of a moment for me when I started to think about we need to find a way, instead of writing the requirement spec and then spending a lot of time on that and then starting the development, finding something else that actually supports this agile way of working. And there came this idea. I learned about agile, I learned about the iron triangle, you know, project plan is one angle, requirement spec is another angle, and the people you have is another angle. And you somehow need to squeeze that time. And what is kind of flexible is the quality. So what happens? Your time gets time boxed in Agile. And the quality, you try to prove it for every increment, every time box. And you have all the people whom you have, so the cost for the increment is the same. So what is variable is the requirements, and the requirements go in backlog. And so this is a fractal model, and we started to use it first as a rocks, pebbles, and sand, kind of mimicking this story of time management, that the professor came, this time management lecture, having a big glass jar, and you put first the big rocks, and then you were able to pour in the pebbles, and then the sand, and even some water. And we started to use that. We actually used it with the Symbian operating system, so that they said that, oh, nobody wants to work in sand, so let's call it boulders, rocks, and pebbles. So let's define first what are the big boulders. And if you have been looking around, so this model, I think, is now in use in quite many organizations. So epics, capabilities, features, and stories. So we changed this language when D. Leffingwell came. But it worked nicely, because you can start, these epics can be your big boulders. You don't define them in very much detail. You just say roughly what is the vision that it should be, whether that's a kind of a new standard or something like okay, new, better camera or something, which is built maybe by software and hardware. So many times these epics, they are both software and hardware. The capabilities originally in this model, they were hardware modules. But I've been now working with different companies where you don't know where the hardware is. You can have hardware stories, hardware features, hardware capabilities, and much likely your epics, they are both hardware and stories. And this is allowing us to squeeze time from the requirements. Another story from my past. So year 98, I was in US running a team, and at that time, Bill Clinton was the president in United States, and there was kind of people laid off from defense industry. So I got some people to my team who had background in Raytheon. And when I was interviewing them, they said that, oh, but you know, we start writing specification, there are folders and folders and folders, physical folders. Like we've spent maybe 16 years on writing these specifications before starting a single line of code. And I was thinking like, wow. And then when we start the first line of code, we notice that it doesn't work. So this model helps us to start to work earlier and start exploring things. Because when you talk with hardware guys and you start asking them, how do you actually come up with a new product? Sometimes they don't say that, hey, I start with writing specification. They said, I have these components here, I start exploring. And I put something together, and we do a prototype, and we see if it works or not. And this is a model that supports also this. Also, another question is this, how do we actually go through the iterations? So we can have different versions or different iterations. And you can put a tag for each of these. And this is kind of how you can go through the compliancy. You can put a tag, what is the capability, what is the requirement that it's fulfilling, and when it's there. And the best part is you can use a lot of AI for this nowadays. And maybe you can build an AI system that consists of all your documentation. And when you have this hardware engineer that is thinking of new kind of things, they can use your internal AI and see if the ideas make sense or not by talking with that internal AI that knows about all the previous products that you have created. So that's something. Flexible contracts. So describe your integration target as module property changes. So how do we actually change these properties? Explore how to evaluate and demo the change in a consolidated view. Which property can we simulate? How can we do the test or simulation? And put it as a needed requirement into your development. And review the module setup and interface definition if needed. And then investigate in outsourcing possibility as well. So, and having these suppliers brought in a way. So we can't just hand over the specifications to them either. We need to work in collaboration. We need to also have an iteration with them. So we need to modify the way how we actually handle these suppliers. From handling them as someone who is coming from external and looking always for the cheapest price, to more on partnership and what we can develop together. I've been working with some of these suppliers as well, and on their side, they see it like it's very hard for us to start to forecast like what's needed 5 years from now. And if they enter into this partnership, maybe there is a possibility to kind of both shorten these loops, shorten the release dates, but also kind of innovate together where the future might be going. And these governments and contracts, so we need to move away from specifications that are locked. So no time to write several years of folders of specifications. In order to allow this smart manufacturing, to allow this metal printing, use of the metal printing, and we might not know the total cost beforehand. So we need to go into innovative solutions, and we need to start doing something that is called cost innovation. So what is cost innovation? It's starting from existing product and innovating with new technology, so that how can we put the price points down when investing in this new technology. So that is something that is very, very hard to specify beforehand. So with the traditional mindset, we cannot kind of go into that. So we need to change the procurement process. It's too slow, and it prohibits this innovation. So we need to be able to build these adjustable solutions and build the contracts around the desired outcomes and give teams the liberty to innovate against the given visions. So how do you feel about this? So all of this that I just presented, it's in the first white paper that I wrote. And when I present this to someone, and when I got some feedback from this white paper, so one hardware manager in a quite big company said to me that I read your white paper that I couldn't understand a thing about it. I was like, okay. And then I got another guy, and he said that, yeah, we implemented all of that already. What's new in it? Why didn't you put any new things in it? And the guy came from this organization. So I was lucky enough to have them as my clients. So I was a coach in Wärtsilä. And out came from this hardware and software agile way of development came this flexible engine that is using first time in the world the ammonia as a fuel, or they can actually use any fuel, different type of renewable fuels. So that's actually quite big thing. So if you think that we are only talking about drones, you are wrong. We can also do these very, very big things in an agile fashion. That's why I have this slide here. But we have still to talk about the variance in weeks and not years. And this is where my other white paper comes into play that I've been working now with Joe Justice so much. So we start from these increments. This is my best understanding currently, how we can get in the speed. So we need to start from whatever we have currently, and we need to understand these increments. So all the things that we said before, with that we go from these releases from every few years that we get as a result of a waterfall to quarterly releases. And this flow-based development. And then we need to kind of put that needle into the several releases per day. And this is what is now happening in some companies in the world. So, I'll come back to that. So it's not synchronized, and it allows really, really fast innovation. So how this is done is we need to put the software first. And I said that already in mobile phones we were doing software hardware iterations within days. And that's because first time we were able to actually decouple most of the software from the hardware. So only the hardware drivers need to be at the same sync with the hardware development. But when you are able to test the new software with the old hardware and the new hardware with the old software, you are actually speeding up quite significantly. And then you have to have this system architecture modularity, this new type of modularity that was visible in this SpaceX type of working. So where each of the hardware modules must kind of adapt to whatever is the surrounding. So this means you start defining the interfaces first. And you have pretty much standard interfaces. And you need to have these layered interfaces like in TCP/IP protocol. I see some people nodding. And when you put this software first, it's enabling this. Hardware needs to support the multiple versions of software. So this is actually already giving you some of the variability really, really fast. And then the economic benefit will be on maintainability, durability, and upgradability. But also when you are able to actually replace some of the modules, or you start to think about your product as collection of a lot of modules, where some modules you can actually define that they only run a certain time, and some modules have a different life cycle. So you can kind of plan this upgradability into the product itself already. And it's also enabling this product as a service business model. So there are some examples of that in Netherlands, where you can actually rent a fridge or refrigerator or some of the other appliances to your home, and they are getting replaced if they are malfunctioning. So first thing that is usually going wrong is our roadmaps. So so far, all the traditional roadmaps that I've seen in different organizations, they are looking something like this. So you have hardware version X, and then you have software version X built specifically for that one, and then you have a release. And this is a problem because there is already delay in build. So, and then you have to have a lot of different software versions that are supporting different hardware versions, and that is causing a lot of complexity within the organization. And you're losing a lot of capacity in the organization, development capacity, on just developing different variants of the software that are supporting different variants of the hardware, and it just doesn't work. You know what is a complexity explosion? So this is the thing that is often we think about this as a linear growth. These things like, okay, this is just another software version, and we forget about this complexity. But you know, exponential growth is thinking about, like, you know, there is this story about the person who invented the game of chess. And when the kind of the king in India who received this game first time asked, how would you like to get paid? He said, put just the one rice grain in the first square, and then you multiply it into the second one and third one and so on. And you know, this is going more than exponential growth. And finally all the rice in the world doesn't fit there. So this is sometimes, I think, what kills our nice projects. We go suddenly in this exponential combinatorial explosion, and we need to cut through that. So we need to do these vertical slices. Sometimes, you can have software and hardware co-developed in some cases. This is not suitable in all of the cases. Sometimes it makes sense to have like hardware platform and this kind of isolation layer and the software on top of that. And sometimes it makes sense to have something like co-developed. I give an old example because this is not violating any of the NDAs that I have. So for example, when we were developing this Nokia phone, the camera was, hardware software was co-developed, so developed it together, because some of the functionality could be implemented by software, image quality, and some could be improved by hardware. And then we have multiple versions all the time under development, and we just very late, just before the launch, decided which version we are going to put in which product. So this is cutting both the development cycle, but it's also enabling you to play, kind of understanding how are the price points going down, and how you can kind of implement the best possible image quality with the cheapest possible price. So you need to understand the business logic behind, and you need to understand how you are using this vertical versus horizontal for your benefit. And there is multiple books about this software hardware co-development. So it's cross-disciplined whole team, and economics of prototyping and hardware unit tests and vertical slicing that is enabling this co-design. And benefits is that you avoid these big surprises and you are able to validate these designs faster. Also, kind of another thing that is pretty new is this, that McKinsey has recently stated, which I truly believe, that what is actually building the competitive benefits nowadays is that you have an advantage of your own AI. And this we need to understand in relation to our development organization. What parts can we actually, and where should we develop our own AI so that we can benefit from it as a competitive advantage? And it's not meaning that some developer is using ChatGPT in their own corner. That's not it. It's something else. So this is where we have been collaborating with Joe Justice. So Joe Justice has come up with this idea of mob AI, where it's basically the team is using so the AI is a member of a team, and the team is using AI as a cross-functional team. And this is now used in SpaceX, in Waymo, in Toyota, and in Amazon. And what we have been finding out when we have been applying this and helping customers to take it into use is that something very strange happens when AI is a team member, because for some reason the innovation starts to be more rapid and starts to be natural part of the development. So something that we can ask very stupid questions from the AI is allowing us to ask very stupid questions as a team, and this actually starts the innovation within the team. And it needs to be cross-functional, because this is then that you have these multiple viewpoints happening at the same time. So we want to remove the silos and organize teams along the value stream. So we need to understand the value stream, understand what is happening there, and understand if we are using this vertical slicing or horizontal slicing, and put teams into these mob AI teams. And we can also use mob AI change team. So how to do this kind of transformation. So why not to have this team who is doing this change for the organization? So how do you start an agile transformation? You find people who are motivated, and maybe you have already some people who are interested about AI tools, and they create this guiding coalition, and you provide the leadership support, and they innovate on these different bottlenecks and problems and celebrate wins. So their task list is an AI vision. So what are the goals for this change and how do we measure the impact? How do we actually gain the benefit as a company? Then an AI governance. So what is our policy of using these tools? What are the security concerns? What is the AI ethics? What is the tool education that we need? How do we actually experimenting this? And how do we communicate the change? And this is kind of like how these companies, big companies who have adopted mob AI, how they are actually working. So they have this, well, most companies are nowadays using OKRs. So, and now we can kind of go away from just talking about product development and hardware to any company. Because we can have mob AI teams also in software organizations. We can significantly speed up your software deliveries. So have this kind of like a OKR type of structure where you have your mission, and that's kind of like what prevents us to reach that mission is the next bottleneck KPI, and each team has a child KPI, like what we want to improve in order to get there. And they are innovating in order to how do we actually get there. And why this is actually so nice, because this is decentralized, and this is allowing everyone to execute very, very fast. And this is also a funny thing when we have been trying this mob AI. Like we have tried different lengths of iterations, so sometimes like 10 minutes, sometimes 5 minutes, and we have ended up in 7 minutes, because it seems like 10 minutes is sometimes too long, and if it's shorter than 7 minutes, it's like really, really short. And then sometimes we get this kind of note like, okay, the 7 minutes is done and we didn't get anything accomplished. And we are like, okay. And sometimes like in the old days, it used to be like weeks or months before we noticed that nothing is moving. And now 7 minutes seems like eternity. So it's interesting. It's interesting. So, very fast. And then you need to visualize somehow, like how would the organization look like? And this is the thing that we iterated a lot with True Justice. Like, first of all, I think this quarterly releases, many hardware organizations, they go first on these quarterly releases because somehow these increments of these bigger systems, iterations of the hardware modules, they kind of like gear you into this 3-month increments. But then when you start to go really fast, you notice that maybe Kanban is actually better suitable for that because it's just supporting this flow and it's supporting these more rapid iterations. And you have your value streams and you have your portfolio that is guiding this all these things, but you can go in this canal free. So you just have every month you plan and then you release whenever you are there. And I'm now thinking that we have actually quite many software organizations that are doing, someone said today, like daily releases or multiple times a day. So how can you synchronize, how can you plan? So this might be something that you want to kind of look if you need to coordinate some bigger deliveries. So because we need some coordinating alignment structure still for that, so that we can run this whole system. Okay, so this is described in this new white paper, which is 10 pages long. So will be available to you as well. So this was quite short presentation. So if you're interested in hearing more, so I have my trainings. So if you take that QR code, you can get a discount to next training, or if you just contact me, I can give you a discount, 20% discount on this. So it's combining all of these things, but it's taking 2 days to explain, not just 1 hour. And I'm happy to take any questions if you have those.